Hey everybody, tonight we're doing a fractional part equation. Now the fractional part function operates on real numbers, so we're going to write down x is just any real number here. And the fractional part has a pretty natural definition. You take the floor, you subtract the floor from the number itself. And let me give you just a quick example. What if we wanted to calculate, and you can do this in your head, but we need a more analytic way of doing it. Let's say you want to do the fractional part of, so let's say 12.9. Okay, well, 12.9 has a floor of 12. That's the greatest integer that's less than the number. And so notice right here you would get 12.9. You know the answer is 0.9, but we need a way to handle this kind of analytically, I guess you may want to put it. So minus 12. Okay, and that's equal to, of course, 0.9. And always, and you can see clearly from these definitions here, that the fractional part has to be a number trapped between 0 and 1. And that just makes all the sense in the world anyway, but these definitions here of the floor and the fractional part ensure that the fractional part of x is guaranteed to be trapped between 0 inclusive, 1 exclusive. All right? Now, this condition of the fractional part being trapped between 0 and 1 leads to this statement right down here. Since this is an equation, the fractional part is equal to this linear function. So notice that I trap that linear function between 0 and 1, which is exactly what the fractional part is supposed to do. It's just that this fractional part imposes that condition on this linear function, which normally has a domain of all real numbers, right? But the fractional part forces it to be trapped between 0 and 1, and we get this statement right here. Now notice this is approximately 7 right here. 22 over 3 is just a little bit more than 7, right? It's 7 and 1. We'll say 7, but it's 7 and 1/3. So we're going to have to look at 4 intervals here, and you'll see the very first interval we'll look at will be the interval from 22 over 3 to 8. Again, that's how the floor function works. It's in an interval of width 1, essentially. Now, so that means the fractional part would be equal to x minus 7 because the floor of any number between 22 over 3 and 8 has to be 7. But notice what happens when we actually set x minus 7 equals to this. We get 55 over 8. We get 55 over 8, but notice that 55 over 8 is actually less. Okay, 55 over 8 is less. It's not in this interval is what I'm trying to say. 55 over 8 is just a little bit less than 7, right? Because 7 times 8 is 56, right? So you see 55 over 8 can't be a solution since it's not even in the interval to begin with, right? So there's no solution in this interval from here to here. So we'll write down no solution. Now that's just in this particular interval. We have to check 4 intervals that are between these two numbers, all right? So now we move along to 8 and 9. You see we're here about 7 to 8, now we're 8, and now we're just stepping through. So the fractional part of any number between 8 and 9 would be that number minus 8. For example, 8.6 in here, you subtract 8, you get 0.6 as the fractional part. Now I won't go through all the algebraic steps here, but we do get that the fractional part is equal to 1/4. Right here, you may want to note that I didn't write this down, but this reduces to 33 over 4, right? 33 over 4, of course, is equal to what? 8 plus 1/4? So, yes, 1/4 is the fractional part of 33 over 4. And notice it's not enough. We have to take the 66. I didn't reduce it, but I substituted it back into the original, right? The original linear piece, right? Remember, it's equal to this part up here, right? The linear piece. And so you have to take, even though we get 1/4 right here, we still have to check if this value 66 over 8 gives us 1/4, and it does. And you can see the work right here, folks. So what we know so far is that 33 over 4 is a solution. So I'll go ahead and just circle it temporarily right here. So 33 over 4 is one of the solutions. We found one of the solutions. All right, now we've taken care of the interval from 8 to 9, so let's go to interval 9 to 10. And in a similar fashion, we get 5 over 8. And you guys can follow that work. Save some time here. And so now we know that, what was the number? 77 over 8? Yeah. So 77 over 8 is a solution. Okay, and all this stuff is about the same. So we finished up 9 to 10, and now from 10 to 11, you guys can check that if you want. But that's where it all stops, right at 11, because again, this step right here is very important to know where you're searching. Okay, we searched in the interval from 22 over 3 to 11, and note that we just broke it down into 4 cases. No solution in the first interval, 33 over 4 in the second interval, 77 over 8 the third interval, and again, you guys can take the time to verify that there's no solution in this interval. So that's it, folks. These circled answers, 33 over 4, 77 over 8. Let me write it down up here if I can remember it. So the solutions are x equals to 33 over 4. Notice there's a clash with the solution set notation here. So I'm just going to write it like this. 77 over 8. Okay, so there we go. 33 over 4. Let me check again. Let's see, is that what it was? 33 over 4 and 77 over 8. And I hope you like that one.